phones away, I'm sure. And some of you guys are just getting right on it. So do me a favor, though. I know, show of hands, how many of you guys have a pretty good handle on how to make a graph? Okay. So I'm preaching to the choir here, okay? I understand that. But just in case you might have forgotten something, or as a review, or maybe I'll teach you one maybe thing new. We're going to see. What are the things that we took down yesterday, the pieces of information called? It starts with the letter V. The variables of the experiment, right? When we were measuring, we were picking up those pieces of information, the variables. All right? So in your notes, maybe a little heading, graphing. What are the two types of variables? No, not you, somebody else. And independent and dependent. This is going to be the fastest review ever. Independent and dependent. All right. Can you tell me the 3 examples of independent/dependent variables that we used yesterday? Go, give me one.
Height.
Height. Which is that? It's dependent. Height. So if it's dependent, what is it dependent upon according to our hypothesis? Yes. Whether we're a boy or a girl, or our age. Good. Those were our 2 hypotheses. Remember, we said based on age, you'll have the older the student gets, the taller they get, on average, right? Or what did we decide? Is there anybody that thinks they know before we even did the measuring whether the boys would be taller than the girls or not in this grade? Yes. Okay. All right. So most of the time we're going to use a standard L-shaped graph. I will be using a scatter plot. You do not have to use a scatter plot for this. It just makes the most sense for me. I had other people today that they wanted to use like line graphs or bar graphs, and then they might have to represent their data differently, okay? I'm just going to show you what came to my mind. First of all, what axis is this? The Y. That means this is the X. Where do our variables go? Does anybody know? What do you think? Yeah. Now, if you can't remember that, I don't know where I learned it, which teacher taught me. They taught me this for a reminder, for a memory aid. They taught me dry mix. And in the word dry, we have a D to help us remember dependent variable goes over here. Independent variable goes here because that's got an I. Does that make sense? Whatever works for you. Did you need that or you just remember? She just remembers. Good for you. Now, so we're going to put height over here. We got to title our axes. Title them. I can't spell. Height. What else might I put in parentheses under height?
Inches.
Inches. Let them know, hey, our measurements are in inches. And that way we don't have to put anything else over here other than the numbers, right? And then, of course, down here we're going to put one or the other or both of the independent variables. I'm going to do birth date. Okay? And here's how I'm going to go about the other piece of information. I'm going to change the symbol. It's a scatter plot, so I can just make the dot for the girls different than the dot for the boys. Does that make sense? So when I make the points, I could have like filled in be the boys, open circle be the girls, okay, or whatever you want, stars, heart shapes, whatever, okay? So on this side, do I have to start at 0?
No.
I had 1 or 2 heads starting to go, yes. If we were doing like quadrant math, then we'd have to be at 0, the point of origin, right? But when we're graphing something like this, it doesn't make much sense because we don't have data until what, like 58, 59 inches, somewhere in there. So we'd have a whole lot of empty space on our graph. So what you want to do is find your total range of information. So find your shortest person and your tallest person. What do we have for shortest? What are the inches? 59.5 inches is our shortest person in class, and the tallest?
71.5.
71.5. Okay. So could we agree that our whole range of data is between 55 and 75 inches? If I put 59.5 at the point of origin here, then my points would be on the actual x-axis line. That wouldn't be as aesthetically pleasing. It wouldn't be as easy to read, okay? So I'm going to put 55 all the way at the bottom. I'm going to put 75 all the way at the top. And that way all I need is 60, 65, 70. So I got 60, 65, 70. My lines, I'm drawing quickly here, but you want to make them as even as possible. Does that make sense? 60, 65, and 70. Am I going too fast for anybody? If you need me to slow down or explain myself, please say, hey, why did you do this or that? As far as drawing it out, you can catch up. But. And then I'm going to go ahead and make the little tick marks in between for each whole number. So I have 56, 57, 58, 59, 61, 62, 63, 64, 66, 67, 68, 69, 71, 72, 73, 74. Not bad. It's almost like I've had a couple classes to practice today. And of course, we measured to the nearest half inch, but you can just estimate halfway, couldn't you? And then bring it over to your other data point. Could you, if you really wanted to, could you have every single day of the year for the year and a half or 2 years range of data on the bottom? Yes. Would that get a little cluttered? Yes. Probably. Do we think for visual representation, because that's what the graph's all about, representing the data visually, right? Quickly looking at it, get a kind of sense. Is there a ton of growth for most people, difference within a month? Like if you had a growth spurt inside of a month, would it amount to more than a half inch of growth? Probably not. That'd probably be painful. Oof, anybody get growing pains? Yeah, it'd be pretty painful if you're growing a half an inch inside of a month. So we're going to do months. You can decide to do other things if you'd like. And certainly if you wanted to get more specific, you can, if we're going to put tick marks for each month, you could go in between them to adjust for the day. Does that make sense? Okay. So what is our range for birth dates as far as what's the earliest month and year? Was there anybody in this class born in 2009? 2010? Several. 2011?
Yes.
Several. 2012? All right, so here's how I do it for this example. I'm going to put YR for year, and above it, I'm going to put MO for month. We have folks born in 10, and we have folks born in 11. And then I will put the months above. What is the earliest month in 2010 that we had a birthday?
June.
Is it June? Okay. So I'll actually start right here with month 6 for June. And then I'll say 7, 8, 9, etc. And I'll start back over at 1 for January of 2011. Does that make sense? Okay. Now, if you'd prefer putting like SEP for September, you can. In my mind, I know their months and I know what the number corresponds to. Okay. Does he have a question back there? Question? No? Okay. All right. We're almost ready to start plotting. And you don't have to make up a title right now, but we just need thinking about what do we want to title this, okay? Remember, we have the thing that we're trying to figure out what the cause is or what correlates to it. So you don't want to just say height of students in your title, because that's just the y-axis. Okay. So we can start plotting points. Who was born in 2010? Give me like one person right here. September of 2000. That's perfect. I went to September so far. So September, and I don't care about the day. What's your height? 71 or 71. So I'm going to go straight up, 70, filled in, because we're a boy. That's my first data point. And the 28th, though, you know, we might think about that. That's almost into October. So maybe I would hedge that over just a little, right? You can do that. Give me a gal. Give me yours. Of what year? 2010. October what? 7th, and the height? 66. And then I might go over just a very little bit. And yours will have that be not filled in. Okay? You don't have to use the same symbology as I am. You don't have to even do the bottom exactly the same way that I am. You might have like boxes, right? You might have, like this might be 6 here. This might be 7, which might work if you're trying to hedge. That might make more sense. It's totally up to you how you do it. What makes sense for you? As long as it can be read by someone else and they can relatively quickly see what you're trying to tell them as far as data. For today, I'm going to give you guys are working so hard, you'll probably be done with 10 minutes to spare at least, and then we can go into the next thing. But I want every data point plotted on your graph. Okay? And I'll check it either at the end of the class today or tomorrow when we come in. Questions? They're just plugging away. What's up?
Can you give us graphing paper?
Nope.
I have paper.
If you have graphing paper or want to share, you guys are rock stars. Just that's awesome. I mean, I did it on a whiteboard with no lines, right? So yes.
So it doesn't have to be a scatter plot, right?
It does not have to be a scatter plot. You can choose any graph type you want as long as you can clearly convey the data. Show the relationship between the variables. All right, cool. So she just brought up line of best fit. I'm glad she did. Because once you're done graphing it and you're looking at it visually, it can help confirm or deny your hypothesis. If you see that the data set drifts off in a certain way, you can take a straight edge and find where it looks like it's about in the middle. And if you can do that, that's a clear indication that you've confirmed there's a correlation. If it's so random and there's outliers everywhere and it doesn't seem to be a correlation, then maybe you haven't established that there's a definitive relationship between age and height. Can you think of a reason that might be? Think about maybe a different age group, right? So if you were looking at nothing but seniors in college, would there be a correlation between their ages and their heights? Probably not. They all, by the time they graduate high school, most people have finished their growth spurts, right? So it just depends. Line of best fit or trend line. How many have never heard that before? Line of best fit or trend line? Everybody heard that? You hadn't? You had not. Okay. Hey, at least I taught somebody something. Or rather, you did, right? Wait, you taught that just now. What?
So if we save them, we just draw them.
Yes, if you can clearly see that there's a trend, you would find a spot where there's just as many dots on one side of the line as there are on the other. You'd kind of just like, where does it look like the line would go? That's why they call it a line of best fit. But a line of best fit shows a trend. And if it doesn't, then there's not a clear correlation or cause and effect there.